The properties that you need to recall: when you multiply two exponents with the same base, what do you do with their powers? Add them, right? Okay, it doesn't matter whether those m and n values, whether those powers are whole numbers or fractions or rational form, still going to be the same. Same is true when you take a power to a power. What are you going to do with the powers? You're going to multiply them. Same as if they are rational powers. It doesn't matter. If you take what we did up there in that sample problem, a product to a power, that power is going to apply to every factor of the product. So this power of m applies to the factor a and the factor b. So again, all of those are going to hold true no matter what. Every single property that we talked about in exponents will hold true with rational powers. So let's take a look at a couple of them. And a couple of them I didn't write here, but they're in your book if you have access to a book and want to look in it. Let's say we take something like this. What are you going to do with this if you're multiplying two exponents with the same base? You're going to write your common base, and then you're going to do what with the powers? Add them. So you have 2/3 plus 1/9. Well, can you add 2/3 and 1/9? No. Not in this form. So you need to turn everything into the same base, or the same denominator. So the common denominator is 9. What do you have to multiply 3 by to get 9? So you have to multiply the top by the same thing. 2 by 3 is 6. So when you add those together, you get 7/9. So your answer, as far as the form that you'll write it, remember, I'm going to have you put the entire rational power in parentheses to designate that that is the case. Now, if you're using your calculator to verify this, you would take x to the power of, again, just like how I'm having you enter it online, parentheses 2/3 times, again, the x to the power of parentheses 1/9. And when you hit enter, it confirms it for you. Okay, let's take a look at 1 over 64 to the minus 1/3. All right, so by hand, if you're working on this, the negative power moves everything to the top. So we move that base of 64 up to the top, and it changes the sign of the power back to positive. Okay, now, here's where you have something that we haven't really talked too much about. But the couple things that you are expected to know regarding perfect powers is you should know what the perfect squares and perfect cubes are. Perfect squares you should know up to 12 squared. Perfect cubes you should know up to 6 cubed. Okay, so are there any questions on perfect squares? Like 1 squared is 1, 2 squared 4, 9, 16, 25. Okay, you should be good on those. The cubes are a little bit more challenging. 1 cubed is easy. 1. 2 cubed is 8. 3 cubed is 27. 4 cubed is 64. 5 cubed is 125. 6 cubed is 216. Okay, those are the ones that are usually assumed that you can get up to that point. So what that means is if you take the cube root of any of these numbers, the cube root of 64 is 4. The cube root of 125 is 5. So when you look at this type of problem, what you should be able to do is you should be able to look at this and say 64, it can either be thought of as 8 squared or 4 cubed. And you need to be able to think of it in either of those forms. Because if you see this as 4 cubed, and then this power of 1/3 applies, what you can now do is take this rule, the power to a power rule, and what is 3 times 1/3? 1. So you get your answer of 4. Now, of course, you guys for me, you guys have that access to your calculators, but that may not always be the case. depending on what math class you take or who your teacher is. Okay? But just to be aware of that, anytime you see something written as a perfect power, you want to look to see, can you rewrite it in any of the different exponential forms that will simplify the problem for you.